All right, thanks for tuning in today. So take a look at the problem that I have on my screen here. Take a look at that fraction. Do you know what that type of fraction is called? It's called complex. Why is it called complex? Because we have a fraction, or actually multiple fractions, inside of a fraction. Okay, this is called complex. Today we're going to be working on simplifying complex rational expressions. Now we know rational expressions are just expressions written as fractions. So let's just start with the numbers. Let's bring it back to this, okay, before we get into throwing the variables in there. So I want to simplify 2/3 over 3/4 minus 1/3. Well, how would I go about doing that? Well, if I just look at the denominator here for a second, okay, I notice that I can probably take 3/4 minus 1/3. Okay. If I get a common denominator here, I know I'd want to multiply that by 3 over 3, this by 4 over 4. We've been over this. This is 2/3 over, let's see here, 9/12 minus 4/12. So that's 2/3 over 9/12 minus 4/12 is 5/12. Okay. Now, this fraction is still complex, isn't it? We have fractions inside of a fraction. Okay. But we have to remember that a fraction is just a way of writing division. Fractions, divisions, they're the same thing here. So really, I'm taking 2/3 and dividing it by 5/12. So I'm dividing fractions, and we know how to divide fractions, don't we? Dividing fractions, okay, we just simply multiply by the reciprocal. Okay. This is 2/3 times, dividing fractions, easy as pie, just flip the second and multiply. Flip this one, 12 over 5. So I got a common denominator, okay, so I could subtract those fractions. Okay. And I change my division into multiplication. Now notice 3 goes into 12 4 times. This gives us 2 times 4 is 8 over 5, 8/5. All right, that wasn't so bad, was it? Okay. But could there be another way to do it? Okay. I'd like to show you that now. So let me copy and paste this right over here. So what did we have to do here again? We had to find a common denominator, a least common denominator, so that we could combine those. What was that least common denominator? It was 12. Well, I want you to look at the denominator up here. Does 3 also go into 12? It does. So one method that I can use here is I can multiply everything by the LCD, which is 12. So I'm going to take this entire complex fraction and I'm going to multiply it by the LCD, 12 over 12. Okay, let's see what happens here. In the numerator, I have 2/3 times 12. What's 2/3 times 12? 8. Over. Now down here I have this subtraction. So I know that I need to distribute my 12 to everything. So 3/4 times 12, 9. Oh, let me keep that blue. Minus 1/3 times 12, 4. Hey, that's 8 over 5. I get the same thing. So really, when we look to complex rational expressions, there's going to be a couple methods that I'm going to use. One of them is to change dividing into multiplying by the reciprocal. But to do that, I have to have a 1 fraction in the denominator, not 2. So that requires me to subtract them to get that down to 1 fraction. Then I change it to multiplying by the reciprocal. My other option is to multiply by the LCD. So let's jump to this one here. Complex fractions, complex rational expressions, I should say. Okay, so my two methods here. One is to multiply by 1. multiply by 1, in the form of what? Well, look back at this one. 12 over 12, that's 1, isn't it? We want to multiply by 1 in the form of the LCD over the LCD. Okay, so that's one method that works. Other method is to multiply by the reciprocal if we just have a fraction on the denominator. So take a look at this one. Okay. Yeah, we just have a fraction in the denominator. Let's try this method first of multiplying by the reciprocal. Now I wish this would have came out a little bit better. That division sign is actually bigger there. We're taking x over 3x minus 2 over x over 9x squared minus 4. So we're taking this fraction and dividing it by that fraction. So let's change this to multiplying by the reciprocal. X over 3x minus 2 times, now we're changing this division to multiplication, so we need to flip this one, 9x squared minus 4 over x. Now I want to simplify this if I can. Right away I'm going to notice the x's cancel. I also notice that I can factor that numerator. There's a 1 up there. There's a 1 down here because that's a difference of perfect squares, isn't it? That's 3x plus 2, 3x minus 2. Okay, difference of perfect squares. It gives me 9x squared. Outside, inside cancel. 2 times negative 2 is negative 4. So then I also notice then that the 3x minus 2's cancel. And I am left with 1 times 3x plus 2 over 1. There we are. Okay, so that's my multiplying by the reciprocal. Why could I do that? Because the denominator was one fraction, not multiple fractions. Now, what would this have looked like if I would have taken the other approach where we're going to multiply by 1 in the form of the LCD over the LCD? Well, we know when we're finding LCDs that we need to factor, because it's our factors that help us determine what our LCD is. So I have x. Can I factor this denominator? Nope. X. Can I factor this denominator? Yes, we just talked about that. That's 3x plus 2, 3x minus 2. So let's talk about what our LCD is. Well, look at the denominator. It has to have a 3x minus 2 in it. Look at this denominator. It has to have a 3x plus 2 in it, so I'll put that there, and a 3x minus 2 in it. Oh, we already have that. So our least common denominator of these denominators is 3x minus 2, 3x plus 2. So what's our trick? Our trick is to multiply by the LCD over the LCD. This is times the top, 3x minus 2, 3x plus 2. On the bottom, the same thing. So as I look at the numerator, x over 3x minus 2 times 3x minus 2, 3x plus 2, notice the 3x minus 2's cancel. Leaving me with x over 3x plus 2. How about the denominator? Hey, the 3x plus 2's cancel. The 3x minus 2's cancel. That's slick. The denominator is only left with x. And now we see those x's cancel, and we get the same thing, 3x plus 2. Let's look at one more here together. So, first method, multiplying by the reciprocal. We can only do that when we're dividing by one fraction. I have x plus 3 plus 6 over x minus 4. If I want to use my multiplying by the reciprocal trick, I need to add all three of these together, which means I need to get a common denominator for all three of those fractions, add them together, and then I can multiply by the reciprocal. But let's use our LCD idea instead. What's our LCD? Look at all these denominators. Isn't our LCD just x minus 4? 1 has to go into it. Well, this is 1x minus 4. 1 has to go into x minus 4. Yeah. So now what I'm going to do is I'm going to multiply my complex fraction by x minus 4 over x minus 4. To do that, okay, I have to be a little bit more careful than the last one. I have to realize that I need to distribute it into every term in the numerator and every term in the denominator. So here we go. Let's do it. X minus 4 times x. X squared minus 4x. X minus 4 times negative 1. Minus x plus 4. I'm distributing that negative. X minus 4 times 2 over x minus 4. What happens with our x minus 4s? They cancel, don't they? That just leaves us with a plus 2. Same thing in the denominator. We need to distribute it to every term. X minus 4 times x. X minus 4 times plus 3. And x minus 4 times 6 over x minus 4. X minus 4s would cancel, plus 6. So when I multiply by the LCD, this is why I like it, no more fractions. They're gone. Now I'm just combining like terms. Be careful, sometimes I'll see students want to cancel those. They'll want to cancel these. Do I have a product in the numerator or a product in the denominator? No, I don't. I can't cancel those. Let's combine our like terms. X squared minus 5x plus 6. X squared minus x minus 6. There we go, that cleaned up nicely. Now, looking at these, I think I can probably factor these. I should just double check, see if anything else cancels. That would be an x minus 3, x minus 2. This would be an x minus 3. Whoop. X plus 2. I see my x minus 3's cancel. Lost that parenthesis. This is x minus 2 over x plus 2. So there's our introduction. Hey, a couple methods that we can use. Multiplying by the reciprocal, just make sure that the denominator is just one fraction. Or, I kind of prefer this way, multiplying by the LCD, wiping out all the denominators right away. Thanks for tuning in.